If you have a Pieta single action army clone or other clones that when you cock the hammer, the cylinder overshoots the next chamber, this might help. So here we have the cylinder bolt. This is what drops into the groove or into the lead. Then the cylinder rotates and it fully seats into the notch of the cylinder. I found that on my revolver, when I cocked it slowly, the bolt would drop pretty much right at the edge. So what was happening was when I'm cocking the revolver slowly, the bolt is coming up and landing on the frame right about at the very edge of where this lead up ends and where the actual notch begins. So it's landing right about there. That's when I'm cocking it slowly. If I'm cocking it a little faster, that means the cylinder is still rotating as this bolt is coming up through the frame. And I think that meant that it was landing, instead of perfectly right here, it was moving a little more to the towards the actual notch. And I think when it was landing, it was hitting the edge, hitting that ledge that we talked about, and it's peening that metal over. When it peens that metal over, that obviously is narrowing the width of the notch, which makes it harder for the bolt to fit in, which makes it easier for the bolt to kind of just skip off it, and then your cylinder over advances. So anyway, here's how I corrected that. So this is my second example of this revolver, and the first one I had to send back because it was doing this cylinder overshoot thing. I sent it back for that, and they fixed it, and I think the only way they fixed it was just by taking this and sanding the sides so it was narrower and it would be easier to fit into the cylinder notch. The issue with that for me is that that is loosening tolerances, and what I was able to do worked, or has seemed to work, and I didn't have to loosen any tolerances. The cylinder is still locking up very tightly on this bolt. The bolt is locking up tightly in the notch. Nothing has been loosened. The only thing that has happened is that now this bolt leg is a little bit shorter, and it now slips off the hammer cam a little bit earlier. So what controls how early or late the bolt will come up through the frame is the legs on this bolt. By messing around with these, you can get them to drop the bolt earlier. You can't really get them to drop it later. So what an earlier bolt drop would look like would be the cylinder's rotating, and instead of the bolt dropping right here, it will instead drop back here. So it just gives it that little extra room, which is what I wanted, because if the bolt is dropping here when I'm cocking it slowly, maybe the bolt is dropping here when I'm cocking it faster. So I wanted to make the bolt drop a little bit earlier, and here's how I did that. So if you can see this little disc that's in the hammer, this is called the hammer cam on this Pieta. This gets points from me because it is a replaceable part on a Uberti. It is integral to the hammer. The reason I liked it because it was replaceable is not because I replaced it, but because I was able to slightly move it in its press fit. We'll get to that a little bit later, but anyway, this hammer cam is what interacts with the legs of this bolt, and it is what the bolt rides on and then slips off of. And when it slips off of that, that is when your bolt comes up through the frame and lands wherever it's going to land on your cylinder. The way that I made the bolt rise earlier was by making the bolt leg slip off of the hammer cam earlier. So here's how these two pieces interact generally. Actually, I'll show you a little bit more about the hammer cam. You can see that it has a thickness to it. That thickness should be about the same width as your leg that rides on it. It also has a chamfered area, kind of a ramp, that leads down to the flat surface of the hammer. So the way these two interact is that this bolt leg will ride on top of that hammer cam like this. See how they're touching, rubbing against each other. When the hammer gets pulled, that bolt presses against the hammer. The hammer cam presses against the bolt leg, pushing the bolt leg up and pushing the bolt down. So that is when you'll see the bolt drop down and disappear into the frame of the revolver. As you continue cocking it back, that leg will slip off of the hammer cam. The bolt will rise up through the frame into the cylinder notch, or at least into the lead of the notch. And then as the cylinder continues to rotate, this bolt will find its home in the notch. When you pull the trigger and the hammer goes downward, that is what that chamfered surface of the bolt of the hammer cam is for, because now that thing can slide in between the bolt leg and reset it. So now it's ready to get cocked again. So anyway, the way you make this slip off of the hammer cam earlier is by shortening that bolt leg. So you can see that right leg doesn't really do anything. Maybe it does something, but nothing that I know of. I'm not an expert in this stuff. But anyway, you can see how much I had to adjust the length of the left leg, and that now makes it so that as this hammer cam gets rotated and it gets pulled farther away, the bolt leg slips off it earlier and the bolt rises in the frame a little earlier. So the hammer goes back, and the length of that left leg is going to control if it slips off now or if it hangs on a little bit later and allows the cylinder to turn a little bit more before this bolt slips off and the bolt comes up through the frame of the revolver and locks into the cylinder notch. So again, by changing the length of that left leg, you can control how soon that slip off occurs. I just did this with a Dremel, and then I had to also chamfer. I also had to chamfer the edge of that so that ramp in the hammer cam slides over it a little easier. So now, just like I showed before, now the bolt, instead of landing right on the edge, it is now landing, about right there when I'm going slow, which means when I'm going fast, maybe it is about right on the edge, but at least it's not over it so much that it's hitting the edge and then peening the metal into the notch. It doesn't seem to be, at least. After doing this modification, I've cocked the hammer, I don't know, hundreds of times, and it has not done it except for like a few times, which is where I think I'm cocking it fast, but then I'm letting up and going slow, and if you do that, it's just it's your own fault, really. It's just not the way the gun's meant to be cocked. I also had to, like I said before, when I had to knock this hammer cam in a little bit, so it had to stick out this way a little more. From the factory, it was only protruding maybe half the width of this leg, so only half the leg was actually making contact with the cam, and it was slipping off in a way that if a wear pattern developed, the slipping off point could have been kind of unpredictable, and it also could have been like really early, I think. Or wait, no, I think it could have been really late, actually. So it could have been slipping off to where it was in the cylinder notch itself, because this is how long the leg was. So imagine how long that leg, if it was properly riding against the cylinder, the hammer cam, which it wasn't before. It was not. When I looked at it, it was not taking the full ride on this hammer cam. It was slipping off like just in the middle of it, which it's not supposed to do. It was doing something like this, like it would get to this point and then it would just slip up and over it. And it's supposed to take the whole ride until it just can't reach anymore, and that's when it slips off. So anyway, when I raised this hammer cam to where it now made full contact with the bolt leg, now it stays on for the full ride until it just can't hang on anymore, and then it slips off. So I think that's going to be a lot more durable and longer lasting interface between those two parts.